Hi everyone, welcome to our basic rules of differentiation video. First we're going to look at the sum rule, then the chain rule, the product rule, and finally the quotient rule. Okay, so we're going to now see how we can differentiate certain functions. So for example, y equals 4x2 minus 1. So in the previous video we saw how we do these independently, but now we're gonna do them together. dy by dx, you take each term independently. So this is one term, this is your second term, and this is your third term. So if we do the first one, we do 4 times 3x 3 minus 1, that's your first term, minus 3 times 2x to the power 2 minus 1, and if you can remember, your constant always becomes 0, so that will just be 0. And then if we simplify this, it becomes 12x squared minus 6x, and that's the differentiated version. Now we're going to look at the differentiation of two trigonometric functions, the addition of the two of them, and again the same rule applies. So if you have y equals sine x plus cos x, and in the previous video we showed you how you differentiate these individually, so you do the same thing. So your dy by dx will be sine becomes cos x, and your cos x becomes plus a negative sine x, which then just becomes cos x minus sine x. And that's how you do it for trigonometric functions. So now I'm going to explain how we differentiate a function within a function, and usually we apply this thing called the chain rule, where this is the general formula, but I'm going to teach it to you with using an example. So here we have y equals cos of 3x minus 4. So here we see 3x minus 4 is the function within the function of cos, and we're going to name this u. So now we can separate them as two different functions and differentiate them separately and then put them together at the end. So we have y equals cos of u, and then we have u equals 3x minus 4. So when we differentiate this, we have dy by du, which is minus sine u. And here we have du by dx, because we are differentiating in terms of u. So then we have 3, and the negative 4 becomes 0 because constants don't count in the differentiation. And then what we do is, because we finally want dy by dx, so by using the formula dy by du times du over dx, is going to equal dy by dx. Why? Because the du gets cancelled out and you have dy over dx. So if we fill in now our numbers which we got before, what we get is minus sine of u times 3. And here we can plug back in what we took for u over here. So finally your answer will be negative 3 sine 3x minus 4. So the chain rule is pretty simple. You just need to keep in mind to separate your initial two functions properly, and also know that this rule applies to all the other types of functions that we saw before. So even exponentials, polynomials, it's the same thing. So just to show you, if you have e to the power 3x minus 1, so your u would be this, and this function would be e to the power u. And it goes like that for everything. So when you have two functions which are multiplied by each other, we use this thing called the product rule. And this again is the general formula of how it's done, but I'm going to go through it with you with an example. So if you have y equals 3x squared times e to the power x. Here you can see we have two separate functions, so we're going to name them separately as u and v, like it's done here. So then you have u equals 3x squared and you have v equals e to the power x. Now to fill in the formula you need dv by dx. So here we do dv by dx, which gives us e to the power x, because we know when you differentiate this you get e to the power x again. And then here we need du by dx, so that we do here du by dx, and then we get 3 times 2 times x to the power 2 minus 1, which is basically 6x. Then we just plug these in to the formula, which to get duv over dx is u, which is this one, so 3x squared times dv by dx, which is what we found here, e to the power x, plus v, which is this one, e to the power x, times du by dx is what we found here, 6x times 6x, and yeah, this is our final answer. So in the previous video, we told you how we would explain how we find the derivative of the tangent, and tan x equals sine x over cos x. And because it's a function divided by a different function, we use a new rule which is known as the quotient rule. And again, this is the general formula for applying the rule, but I will take it step by step. So to begin, we need to first name them as u and v, because that's how it is in the formula. So we're going to take sine x as u and cos x as v. And then we can write it separately. So u equals sine x and v equals cos x. And for this part we need du by dx, so we can find that here, du by dx, the differentiation of sine x is cos x. And again, if you can't remember how the rules work, it's also included in the cheat sheet. And then again we need dv by dx, and that will give us negative sine of x. And finally we need v squared, which is just cos squared x. Now what we do is we just plug all of these in to the formula. So du over v by dx equals v, which is just cos x. So cos x times du by dx, which is also cos x. So cos x times cos x minus u, which is now sine x. We'll just put this in brackets here so we don't get confused. Sine x times dv by dx, which is negative sine x actually. So negative sine of x, and close brackets, and we divide that whole thing by v squared, which is cos squared x. And now this can be simplified into cos squared of x. This will become plus because sine x into sine x is negative sine x, but then negative into negative becomes positive. So this becomes plus sine squared of x over cos squared of x. And we know by the rules of trigonometry, cos squared x plus sine squared x equals 1. So then we finally get 1 over cos squared of x, and that is what we saw in the previous video.